Welcome, everyone. Good morning, good afternoon, and evening. My name is Italina Ramos, and I am part of the training team. And please welcome to another LMI webinar for our 2025 series. And to our presenters today is Aiden, Senior Director of AI Solutions, and David Katniss, Sales Territory Manager, who will have a conversation about LMI's AI solutions and deep learning technologies.
So our agenda for today's webinar, some brief introductions, give a little bit about information about LMI technologies. Never want to pass up the opportunity to talk about the company. A review of traditional rules-based tools, and then we'll go into the offerings of our deep learning solutions. I'll be talking specifically about the GoPxL anomaly detector, and then Chris Aiden, my colleague, will jump in and he'll handle the second half of this webinar, speaking specifically about our factory smart AI solutions with a really heavy emphasis on the GoFactory dashboard. So you know a little bit about us. Italina introduced us. It's sometimes helpful to get a feel for who is on this call and this webinar and who keeps joining. So a pretty large percentage of us are in the LMI community. So that includes our distribution channels and partners around the world. Thank you for joining. It also includes our direct LMI employees who want to participate in the webinar. About 20% of you are declared in the factory automation space, which is a bit of a catch-all. It's a bit generic in terms of the description. And then we get a little bit more specific. 10% are in automotive. We really see a nice future for our 3D inspection and AI solutions in the automotive space. And then 5% are from the consumer electronics industry. So we're talking about cell phones and wearables and other peripherals that the consumers purchase. Food and agriculture, this is really a growing segment for us at LMI. We are scanning a lot of food items, not only for finished cooked items for packaging, but as well as raw proteins, baked goods, and so forth. And then of the 100 or so people that registered for the webinar, 3% declare as wood and forest products. This is a bit of a mainstay for LMI. We're scanning a lot of logs and lumber for sawmills. So thanks for joining. And then the rest are in the miscellaneous category. That includes people using the sensors or are interested in this technology for aerospace or building materials, energy, security, and packaging logistics. So anyway, that's who we are, and that's who you are. So thanks for joining us today. For the few people who are not familiar with LMI who have joined this webinar, I just want to take about 90 seconds to introduce us. LMI, we are the global leader in 3D scanning and inspection. And we manufacture a large portfolio of 3D sensors which have onboard processing to run a powerful vision library of measurement and inspection tools. We're based in Vancouver, British Columbia, or right outside of Vancouver, as you can see by the red flag on the map. And we have global reach with offices throughout the world. Customers like working with LMI because our products and world-class support allow us to solve the most difficult inspection challenges. Today, we have about 450 global employees, plus or minus a small number. And we have nearly 500,000 sensors installed in various applications and industries around the world. That's LMI. Machine vision, that's what automatically measures product tolerances and identifies defects faster, cheaper, and more accurately than human inspectors can perform that same task. LMI's Gocator smart sensors combine 3D image capture techniques with onboard processing of powerful inspection tools and algorithms. We are proud to have democratized 3D vision for inline inspection. And our latest machine vision libraries come preloaded onto our smart sensors, analyzing both 3D and 2D data with advanced filtering, part segmentation, array handling, custom Python scripting, and so much more. I encourage you to learn more about our GoPxL software. Um, Again, before we jump into AI, it's probably good to get an idea of like what is the norm here, and we're talking about rules-based tools. And so ever since LMI launched the Gocator, our company has been improving its software that comes preloaded onto our smart devices. This software is considered rules-based, but what exactly does that mean? And although definitions vary depending on who you ask, in general, rules-based tools rely on reliable and repeatable features. If image features are repeatable, then we can deliberately place our software feature boxes around parts of a surface point cloud. In short, we know where the action is, and that's exactly where we put our inspection tools. So that's what's depicted in this slide here. Our current software, you don't have to be a hardcore programmer to use them. We use region boxes, and generally we are placing the region boxes where we need the measurements or the detections to happen. So I think I've spent enough time talking about where we were, and I know this is about AI, so I really want to transition and start talking about what we're all here to learn about. So contrary to the rules-based inspection software, deep learning uses a completely different method for detecting defects on parts. And users of these tools train a software model by feeding it images of good parts, as well as classified or annotated images of bad parts. This model runs at high speeds on edge devices near the locations of the inspection. So in the deep learning space, LMI has two basic offerings, a self-serve and a full-serve solution. I'm going to focus on the self-serve options, and my colleague, Chris Aden, will spend the second half of the webinar giving an example of our full-serve offerings. So looking at the configuration to the left, which is the self-serve solution, it's fairly straightforward. The two primary components of the four are the GoMax processor in the middle box and the Gocator sensor on the right. The system operates on the GoPxL software platform. The box to the top is just simply an HMI screen which shows the results and simplified trends, and the box to the bottom left depicts downstream equipment like PLCs or robots or maybe data acquisition systems. And basically, they represent the actions that must be taken based on the outcome of our AI inspections. So our self-serve uh, deep learning solution is an extension of our GoPxL software that is included with all Gocators. We call them Pro Tools, and one of those Pro Tools is an anomaly detector. And so unlike our rules-based tools which run on the sensor, we train and deploy AI inference models on a dedicated GoMax device that has GPUs. The GoPxL anomaly detector integrates with all of our line profilers, snapshot, and line confocal sensors when accelerated with GoMax. It's an edge-based DIY solution that enables you to quickly set up, train, and run your anomaly detection models with minimal cost and effort. Users can train and deploy the solution all on board a GoMax without relying on cloud or offline processing power for initial and subsequent model training. And because it uses GoPxLs, users can continue to employ rules-based measuring tools while calling AI detections in the same job files. Today's webinar is not meant to be an in-depth training on our GoPxL anomaly detector, but LMI has an excellent recording of our previous webinar on our YouTube channel if you want to stay tuned for that. It's a step-by-step tutorial. Feel free to investigate it or contact one of your local territory managers to get the link or simply to find out more. And finally, the key features of our anomaly detector. So our intuitive software enables users to train AI models on the 2D intensity as well as 3D height map images to have the most accurate detection solutions. So it's really using several sources of information. You don't have to purchase the license. This is a bit unique. You don't have to purchase the license until your team is convinced that it will work for your application. So you can perform your own feasibility studies. A license-free evaluation is available with firmware running on GoMax in replay mode. The anomaly detector license comes in the form of a USB dongle that plugs into a port on the GoMax Orin or Orin Plus models. For the third part here, we understand that labeling images is a necessary chore. The most effective deep learning models come from real production images. Although our GoPxL anomaly detector software can strengthen model performance by inserting images from synthetic defects and augmented frames. So it's a combination of real world information as well as enhanced images. And then finally, the transition from the developer's benchtop to the production floor often reveals unanticipated variations with new conditions. We at LMI are very sensitive to this, and our products reflect this real-world need. We created software which allows our users to quickly enhance models that include edge cases by using image data sets stored directly on the GoMax unit. So with that, that kind of concludes the anomaly detector, the DIY anomaly detector, and I want to turn it over to Chris Aiden to take the reins. Thanks, Chris.
Thank you, David. So I'm going to present a live demo of what we're calling our full serve product offering, and we're going to spend most of our time talking about GoFactory as basically a inspection management platform that is designed with deep learning models and AI-based inspection in mind. But I think it's worth looking at the total value chain here just to break down what needs to go into these systems in order to get accurate inspection. And really, it starts with the vision sensors. You have to get good data. All of these systems are dependent on good data. And at LMI, we provide both 3D sensors, but we also have partnerships with our sister companies, TKH Vision, for accurate area scan and line scan cameras as well. So you're able to get all of your imaging hardware directly from LMI as you start thinking about a deep learning based solution. The second piece of that is it's the AI optimized vision controller that we call the gadget. And it was designed with deep learning based inspections in mind. The implementation of the pipelines uses the format that is used by the deep learning community. So you can get models directly from the community and use those for your inspections. We generally support out of the box all of the state-of-the-art models that are referenced in GitHub and around the world for accurate models for computer vision. Other things the gadget does is it communicates to many sensors, so it's event-based, multi-sensor, multi-pipeline. It is capable of consuming as much GPU resources as you have. So if we install on a GoMax, you have a certain amount of GPU horsepower to throw at your problem. And if we need more, if we need to go faster, if the images are bigger, then we can also install the gadget on a server-based or desktop-based platform to get access to more compute resources so that we can keep up with the line speed. So that's the inference engine, and we'll do a brief demo of that as well, again, with the focus to be in GoFactory. Now, with GoFactory, what you get is the ability to manage all of those inspections, whether it's deployed in a single line or across a fleet of inspection lines, either at the same factory or even at multiple factories. And we will show how we can centralize the data. And once you have the data that's centralized, you can do things like optimize your model. You can bring data sets together from different sensors. You can train models. You can do analysis. And then ultimately, you can distribute those models out to your fleet of devices or, again, your single device. So what that also does is that enables us to not just centralize the data and the processing, but also manage all of the different variations that might exist across the fleet. And I think the last piece that's very important here is that because this GoFactory platform resides either in the cloud or on a server that you've installed at your factory, you have access to a lot more compute resources to train the models. It usually requires about 10x the computing power to train a model versus running a model. And so if we can offload the training to something with more horsepower, then you're not going to necessarily suffer any limitations of using an edge device. So these are just some things you want to consider when you're looking at LMI's offerings. So this demo is going to be in the context of weld inspection. And what I'm showing here is the main tasks in order to inspect a weld on a manufactured part. So again, like I said before, the most important part is to get high quality images. And so what I'm showing in the cartoon is a Gocator. In this case, for this data that we're looking at in the demo, we used a 2520 Gocator in order to scan the welded parts. And the next step is we need to locate the weld region. And like David said about rules-based inspection, if your features are reliable and repeatable, you can train your model to find a fixture based on those features and then reference all of your tools relative to that. Well, as you know, or you can imagine with weld, every weld is going to be different. And so high variability is an area where deep learning based models really thrive. And so the first step of this pipeline is to locate the weld. The second step, and where we'll spend most of our time today, is on the inspection piece. So once we have the region of interest where the weld is, then we're going to go in and apply, in our case, another deep learning model that's been trained to find different types of defects. And so you can imagine if you want a single system to locate many different types of welds, you could train your locate part of the pipeline to find the different types of welds. You could also train it to classify the different types of welds. And then you could use that to identify the types of inspection to do downstream. In this case, the simple case is we're going to find the weld, many different types of weld, and then we're going to inspect for the same types of defects. So let me back up, and I'm going to switch over to the demo. So where I'm going to start is with the gadget. And so what you're seeing right now is what we call the gadget app. It's a browser-based HMI that is designed to show the operator exactly what's happening at runtime. So I mentioned a two-stage pipeline. So on the left-hand side, what you see is the Gocator images that use both the intensity data and the height map data in a blended fashion to give us a high level of signal to noise so that we can find the weld region. And the black bounding box is exactly the region that we found. You also see the confidence that the model has for finding the weld. That's on the left-hand side. In the middle, you see the zoomed in part of the weld. And in fact, what this is, again, it's a multi-stage pipeline, is we identify the part of the cloud that includes the weld, and we apply another, I would say, another form of pre-processing to this region of interest that gives us, again, high signal to noise inside of the region where we're going to be inspecting for defects. So again, we're using the capabilities of the Gocator 2520 to generate, I would say, aligned point cloud with intensity data, and we're using the information from both to train a high precision model to find these defects. We'll review the types of defects that are there, but offhand, you'll see porosity, you'll see blowout. We have let's say, failing defects like spatter and exits. But this is just an example. For your application, they might be different. On the right-hand side, we're just showing some charts that will track what the inspection system is doing. So again, if you're an operator and you want to make sure things are working well, then you might be monitoring the defect counts that are coming up. You might be looking across an entire shift and care about the distribution. If I reset this, then we'll reset the distribution. The other thing you might want to do is take a look at some of the finer points. And so we can zoom in, pan, and look around. And one of the things you'll notice here is that the system, the gadget, continues to perform the inspection, even though the operator is looking at a past sample. And so again, the gadget was designed with high performance, high speed, multi-sensor, multi-pipeline inference in mind, and it's been optimized for that task. What you see on the bottom here are the indicator lights that say, yes, we're connected to a sensor. The pipeline is up and running. In this case, the automation service is what would communicate to a robot or PLC. Obviously this, well, maybe not obvious, it's not connected because we're actually running a sensor emulator on a server. In this case, it's at this IP address. And then there's the part that we're really going to focus on for the rest of the webinar, which is GoFactory. And what's happening here is the gadget is sending information about each one of these inspections to GoFactory. So let me switch over to GoFactory and we'll start taking a look at what's there. So GoFactory has really, there's 5 main pages. There's a dashboard, there's an inspections page, data sets page, annotation, and models. Generally speaking, when we're supporting our customers' applications, we start with the dashboard. And these dashboards can be configured for whatever the KPIs or business needs are for the application. In this case, it's a demo. We're showing pass-fail. We're showing all of the types of defects that were accumulated over a period of time. And then we're showing things like processing time and CPU load and RAM. We can show temperature. Anything as either an end user or an integrator who's managing this system might want to know about the current state of performance, but might also want to know if you're approaching any limits and you may want to act before the system goes down. So the system is very interactive. We can zoom in on different ranges of time to find different observables within those windows of time. And again, these dashboards are highly configurable. So let's say, for example, that we've seen an area where we think the inspections are interesting, and maybe the task is at this point is to identify some shortcomings in our model, gather some data, and then maybe we want to retrain a model and deploy that model so that we can start to see improvements in our inspection. So I might go down here and say that was the last 5 minutes. And then I'd say, okay, maybe there's something interesting in the last 5 minutes. And that's when I go to the inspections page. So the first thing to do in the inspections page is to do a quick query and say, what's going on here? And so I'm going to do a search over the last 5 minutes. And what's happening was the gadget had already communicated different metadata. In this case, we're seeing pass or fail, as well as communicating certain thumbnails for each inspection event. Why thumbnails? So usually GoFactory is deployed in the cloud, and what we want to do is minimize GoFactory or the gadget's footprint on the customer's network. The network could very well be cellular. We've deployed plenty of cellular systems. in that case, we want to make sure we're communicating as little as possible to GoFactory, but enough information so that the stakeholder who's managing the inspection system can interact with the data and identify the important parts. So in this case, we see all of the inspection events over the last 5 minutes. In this case, there were 282. Now, what's interesting here is inside of GoFactory, we might want to look a little closer. So let's look at this inspection event here. I'm going to click on it. So what just happened there was GoFactory said, notice that the user clicked on a certain inspection event, and it then reached out to the gadget and said, give me the high-res image or scan data for that particular inspection event, and that's what you see here. So while we say we can, and we do only communicate thumbnails to keep the size of the packet small when we're using the network, when we need high-resolution data, and you're going to need it later when you do modeling, you can't train a model on thumbnails, then we make it available in a as-needed way by just clicking on the thumbnails, and then GoFactory fetches the data directly from the gadget. So that's one example. Now, we're going to talk about model retraining, and one of the things about modeling, if you guys have put any thought into or time into deep learning, is sometimes you, in this case, you already have a model that's deployed. And what you want to do is you want to improve that model. So the first thing to do really is to make sure that you can start from what the model's doing today and make improvements on that. So how do you do that? What you do is you make sure that you can get the model predictions. So that's what I'm clicking here, is the model predictions based on the samples that were done in this query. And then I'm going to get the image that was used for that stage of the pipeline. And then let's say I'm going to select all of the inspection events. And so what happens here is you highlight all of these inspection events that you care about. Now we need to get these to our GoFactory server so we can do something with that data. Again, remember I said that the training takes place in your GoFactory server. Usually it's running in the cloud. So I'm going to push to cloud. I'm going to give it a name. I'll say weld demo webinar. And we're going to create an annotation project. And I'll show you what that means in just a second. So what's happening now is GoFactory said to the gadget, I want to get all of those high-res images for the inspection events that I selected, and I want you to create a data set that I can use for, let's say, a modeling task or other tasks. Maybe it's for archiving, but I also want you to automatically create a labeling project. And so we're going to jump very quickly over to the data sets. Here's the data set that I just created. The top artifacts in this data set aren't very interesting. It would be just the label files, but we can also look at the images as well. And so the data set's been created, but let's go to the next step of the process, which is the annotation. So this is the data set that we just imported, and we imported it into what we believe is the leading labeling environment for computer vision applications called Label Studio. And it's integrated inside of GoFactory. So there's a couple subtle things about this, and I think the most important is that if your labeling environment is integrated in your cloud platform, that means that anybody who has access to this platform can help with labeling. So for a lot of our customer applications, the AI solutions team will partner with customers to quickly label many, many images so that we get good data into the model. Like David said earlier, you can use augmented data, you can use synthetic defects, but nothing's better than the real thing. And so to be able to distribute the labeling across many different users is a huge time saver. Also provides traceability. So that's one of the benefits here. So we have prediction results. We're going to go ahead and convert those prediction results to labels. This is just a simple single click. And then let's take a look at what the model's predicting. And so we see things like, in this case, this was undercut. And we see some spatter right here. Let's say that we want to add some spatter. Let's say the model's not being precise enough. We're going to come in here, add some more spatter. Just pick a few. Very simple. And we're going to update this image. And let's say we went through all of these and we provided additional labels, or maybe changed the label from a mistake that was made. Then we can update the data set like I just did, and then we move on to the next step of the process, which is actually the modeling. So the way that the model pipeline is implemented in the gadget, there's different model roles in a pipeline. Very seldom do we see pipelines that have a single deep learning model, at least two usually. And so what we refer to those as is different roles in the pipeline. And so let's create a new model. It's the weld application. Remember, there's a foreground model role and a defect model role. We're going to focus on defect in this webinar. And we'll call it weld defect webinar. Okay, and so now we go to the next step. We said we want a new model. Now let's train that model. So you have options for training different models. This is actually beta software, and we're right now showing YOLO V8 for object detection, which was state-of-the-art probably about 6 months ago. We've moved forward. I think now we're supporting YOLO V11, as well as the Detectron 2 models, which will be in the release product, which should be next week or perhaps the week after. But we're going to just jump in here real quick and modify some of what we call the hyperparameters, which are unique training parameters for a respective data set. So in this case, I'm going to change the size to 1024 pixels. And I'm going to tell the model that this is a rectangular and not a square sample or set of samples that we're going to be labeling. I'm sorry, training. So now we're going to import the data that we just labeled. So I'm going to add a data set. And let's go to the data set that we just created and labeled. Now, what's interesting here is we could very well also add any data set from any number of devices across, like I said, many different lines, many different sites. You have the ability to add all of the data from really any inspection that is for a line that's doing exactly the same thing. And that goes back to the idea that for a deep learning model, it's not just that you won't expect to find reliable, repeatable features. You almost bank on it. And so by adding data from many different lines that have high variability, you're going to end up with a much more powerful and accurate model, even as you go line to line. And we've proven that many times for many of the applications we're looking at. For the sake of the webinar, we'll focus on a single training data set, and we need to add a few operations so that we're consistent with the pipeline. And so we've put these operations in based on our experience and what it takes to modify the input images based on a typical set of, let's say, pipeline requirements. So something like resizing and then cropping are pretty standard for us. And I'd say for the industry. And basically what we're doing is we're tuning the model to give us maximum performance and maximum throughput. You can always use full resolution. A lot of times you don't need full resolution, especially since we've already cropped out most of the foreground, and the native resolution of the 2520 is actually very close to the settings I have here. But this regularizes the shape so that we can move into the training part of the model. Okay. So now let's move to the training part. We've got the model selected. We've done our pre-processing that is aligned with what's happening in the gadget in the pipeline. Now let's go to training. So this is all of the data that we just worked with. Remember, on this image, I added a few bounding boxes for the spatter defect. So you see that right here. And what I'm going to do is I'm going to automatically select at random 80% of these. And those are going to be used for training. And what's not used for training is 10%, which is validation. But you might say, well, 80% and 10% doesn't add up to 100%. And that's correct. That's because for this particular example, we're going to keep 10% as what we call test data, which is this is data the model's never seen before. And we'll show you why that's important after we're done training. So we've, again, selected the model. We've done some simple pre-processing on the data. And now we're going to train the model. Okay, so what's happening right now is GoFactory sees that the user has decided that they want to train a new deep learning model, and it's provisioning all of the resources that we need to train the model. So what does that mean? In general, is it's creating a virtual machine in the cloud that has the GPU resources to actually do training. And again, generally speaking, you have 10x more GPU resources than you need versus something like inference. And so that's part of it. If you choose to use GoFactory in the cloud, you have infinite flexibility. If you have some RAM bottlenecks you're worried about, then we can provision a VM to have more RAM. If it's CPU that we're worried about, we can throw more CPUs at it. The point is that you're using these cloud resources for the most computationally intensive part of this whole process. You're not dependent on what's going on in order to keep up with the line speed on the edge. So right now we're training, right now setting up to train, I should say. And so this particular model, I think, takes about, it'll probably take about 10 minutes to train. So we're not going to wait for it. But what we are going to do is take a look at some of the feedback and the metrics you're going to get. So what I'm showing here is the model that we just trained before the webinar. Well, this is the model we're training now. And so you see things like the precision and recall. It's going to be very noisy initially. That's pretty standard for one of these trainings. And then it's going to converge on certain value. You see the different losses. So if you're familiar with training deep learning models, you know that you want to monitor the loss both in the training and the validation set, where you can see that your model's converging in both sets. The validation is the one you don't care about, or I'm sorry, is the one you care the most about. And so that's the row along the bottom. And so we've got elapsed time here. You can count the number of iterations in the charts. And basically what we're doing is we're training this model. So let's go back to we're going to let this run. And we're going to go back to the models page and look at a model that we've already trained. Let's look at go back. Dun, dun, dun. All right. This is the one we're trading now. Okay. This is the one we've trained. Okay. So you see this model actually ran for, that's version 2. Let's look at version 1. We let this one run for 1,000 steps or 1,000 epochs in the jargon of the trade. And so what you see is, if I first take a look at the loss curves, this model is fairly well converged. Well, what does that mean to us as practitioners? We might want to look at the data. Let's see here, trading. Rather, let's go to testing. Go back one. We didn't test this one, so we're going to go look at the one that we used in testing. And let's look at the predictions. So this was similar to the problem that we set up that's training in the background. And what we're looking at is a comparison of the ground truth, which is what we labeled with the Label Studio based on the prediction data of the model that was deployed, and what we're actually predicting. And this is the test data, the portion of that data set that the model's never seen before. So if you're trying to get an understanding about how good your model is, best to use data that wasn't used in training or validation to determine how good the model is actually performing. And so you see some things here where maybe the model didn't do a great job. It's not getting this blowout from the ground truth. In this case, it's being picked up. So this is, again, this gives you some indication about how the model's doing in a very tangible way. You see what was labeled, and we see what was predicted. So another thing that might be interesting are what I would call the traditional metrics of especially something like using defect detection. And it's really the concept of precision and recall. Precision tells you basically how many good parts you're going to scrap because of false positives, and recall is going to tell you how many parts are going to escape the factory, even though they actually had some defects. So if you're looking at precision, you're thinking about false positives. As the confidence goes up, you're going to get fewer false positives. So you see the precision going up. What you also can see is that each one of the defects is going to have a different precision curve, and that's because we're looking for, in this case, 5 different types of defects, or I should say 6, 5, and then there's all classes. And the model is going to do better or worse depending on the difficulty of finding the defect and then how much data you have for a given defect. And so that would be our precision. Recall, again, we're looking for the escaped bad parts. And so you know then intuitively that as your confidence in a defect goes down, then, I'm sorry, as your threshold for confidence comes down, you're more likely to find more of the defects. And so you're going to end up with fewer false negatives as your confidence comes down. And so if you put those two together, you get really the classic precision recall curve that gives you a sweet spot, and it usually is around 0.5. So these metrics are very helpful after you've done this a few times at really understanding the quality of your model. The last thing that's interesting to look at, especially in the context of GoFactory and some of the thought we've put into the UI, is what we call the confusion matrix. And really what that does is gives you an intuitive tool for finding out if the model's making mistakes, why. And so on the left-hand side, we have the prediction. On the bottom, we have the ground truth. So let's look right in the middle at porosity. So it's basically what this chart is telling us is we're making 4 mistakes here. If this is the ground truth, we're saying that the model predicted or did not predict 4 instances of porosity, but it did get 14 right. And down at the end of the row, you see that what we call as a hallucinated column. This is one where there wasn't porosity, but the model says that there was. So if we look at, again, what that means for confidence, if we tune the confidence down here, we're going to start to see these numbers are going to change. So let's go all the way down to 0.2. And so we're at that number has come up to 7. That means we're set the confidence at 0.2. There's a lot of objects of porosity that the model found that have a confidence higher than 0.2. Therefore, we're starting to hallucinate a little bit. And vice versa, we go up to 0.8. We're not hallucinating any at all. But now we're missing some of the porosity defects. That number went from 4 to 5. Okay, so once that is done, we have the option to deploy the model. So let me just show that. Go back to the models. Let's look at the model we just trained. I believe this one is still training. And what we would do is we're going to have to wait for that to finish. So let's go back here. Let's look at the training metrics. And that is, we have a stopping threshold that's there. But what happens when we get to the termination of the training, we have the option to deploy. And in this case, these models have already been deployed. And let's see, I will go back to the existing models. Version 2. So this model has already been deployed. And what happens here, and if by the end of the webinar, if this model training is done, and I expect it to be, I will demonstrate this. But what happens, we have the option to deploy a version. And immediately you'll see that the gadget, or it could be the entire fleet of gadgets, will be notified that there's a new model to deploy. And then we have the option to download that model from GoFactory to the gadget, and then load that model, and then you would start inspecting based on the new model revision. Okay, so that really concludes most of the content of the demo here. Let me just check one more time on the training that we've started to see if we are going to be able to demonstrate that. Looks like we are still training, and we are still converging. Okay, so why don't we wrap up the training, I'm sorry, the technical part of this demo. And I will move back to our slides. Let's see here. Elaine, I don't seem to be able to move the slides now. There we go. Okay, so I just want to remind you what we reviewed in this part of the webinar, which is one, that you can get, well, data's king. And you need good data to build any deep learning system. And you can get the high quality 3D and 2D vision sensors that you need from LMI or from TKH Vision. And it's garbage in, garbage out. If you're not getting good data, then any deep learning model you use is going to be very, very much limited in the performance you can expect. We also provide a highly tuned vision controller for inference. And it was designed with deep learning in mind. It was designed with multi-sensor, multi-pipeline, high line speed type inference with connectivity to GoFactory to do the heavy lifting for model training with a browser-based HMI so that you can connect to the system and observe performance. It was designed with these things in mind. It is not a Swiss Army knife. It is a highly tuned vision controller for deep learning. And then the piece that we spent the most time on today, which for a lot of applications addresses a lot of the iteration in developing, deploying deep learning based solutions, is GoFactory. And what we showed was we've got centralized dashboarding that support both single system as well as fleet level performance monitoring. We can centralize the data for curation and then create models that are trained on many different data sets. We have shown a streamlined image labeling and modeling infrastructure. So that's using Label Studio for efficient labeling, and then the hopefully very simple workflow for training and deploying new models, and the ability to take a model that has been trained on many different lines or data from many different lines and very quickly deploy that to a fleet of devices is something, again, that makes this whole process feasible. If you have to do it all one by one, then it's a nightmare. And so these are the tools that the AI solutions team has been working on and developing for, I would say, the past 5 years. and they are being made available now through our services, but also to sophisticated end users and partners that want to take on some of the support of these models themselves. And if you're either one of those end users or LMI partners, then we'd love to have the conversation and engage on any applications you might have where you think any of our AI solutions could be a good fit and help you with your inspection needs. So with that, I'll either hand it back to David or we can start with questions.
Yeah.
And did we have the first question in the chat? Lauren Snyder is asking about, are these realistic numbers for the kind of defects, in the sense that when we have 14 parts with non-defects, but 4 of them are not defected by the model, that strike as high?
It depends on the application. We had very limited data here. There was only 102 unique samples. And right now, I would say that generally speaking, we look for, if we have 5 defects we're looking for, anywhere from 20 to 50 samples per defect, depending on the application. And so it's hard to say. It really is application dependent. We have some applications where there are upwards of 500 to 1,000 images or scans in a data set. We have some where a couple hundred is sufficient. We have some where 30 is sufficient. It really depends on the application as far as that goes. But again, that's where the iterative nature of deep learning and experimenting with data and labeling is so important, and the ability to get that data from the edge system, the production system, is vital to really minimize the amount of data you need.
If I could put a bow on this, just as a reminder that we have, this do-it-yourself product offering in the GoPxL anomaly detector, and then we have a full serve solution, which Chris spent a really good amount of time explaining in great detail. It's a very sophisticated system. That's why, to be honest, it's offered as a service to those who don't have the engineering staff to implement something like this. We will do it. And these tools are very, very powerful. And the reason why they exist, I mean, beyond just the dashboard to show the statistics and to allow people access to the images if they want to query, like, why is, what is it finding, what is it not finding? You can get at all that data. But most importantly, and I don't think we can emphasize this enough, is in our experience, this is an iterative process. You don't just deploy an AI model and it works right out of the gates. I mean, yeah, okay, if you're inspecting baked goods or something simple, that's pretty easy. You can do that with a couple of images, and you can get away with using a DIY solution. But for something like a weld inspection or the kinds of applications that we see routinely on a monthly basis, retraining is necessary, especially when it's deployed across a fleet in multiple lines, multiple factories. And this solution gives us the access to all of the images and all of the data so that we can retrain a model to improve it. And we can do this remotely. And that is an incredible time saver. It's very, very valuable. And I think that's just the one thing that I wanted to emphasize to this audience, that we recognize the need for retraining, and we have created the tools to make that possible so that the models can constantly be improved whenever that's necessary.
Thank you. David, we have, and Chris, we have a couple of more questions in the chat.
Mm-hmm.
Would you like to address?
Is there a plan for classification option for DIY system with Orin? I think we have only anomaly detector for now. Yes, that is the plan, is to have not just an anomaly detector, but also an object detector in future offerings. Yes. Hi, how can distributors and potential customers test the GoFactory platform internally, and how is the pricing model? Thanks. So, Chris, I'll let you answer that.
Sure. I would say reach out. That's the best way to get started on an application. GoFactory is required for any of the new projects that the AI solutions team will take on, because it's the only way that we can do the work to develop and deploy and support the models efficiently. And so if we identify an application that we think is a good fit, then engage with us and we can work through it together. And then once you've gone through the process and you understand how these tools work together, then by all means, we can set up some sort of a arrangement and agreement where you guys could use these tools as either a license to both, and which is probably how it would work. If it's something that's deployed on a on-prem server versus in the cloud, there's probably a perpetual license that we would explore. But I'd say if you want to understand if this is a good fit for your organization or your application, please reach out to us and let's find an application. Let's work on it together, and then we can take it from there.
And we'll probably have the pricing discussion at that time as well. But I've written down your name in this question, and we'll look up your registration information and be in touch. Are there any other questions? Okay. Well, with that, thank you. Thanks for taking an hour out of your day to join us and to learn about this topic. And we look forward to working with you in the future. Thanks so much.